Welcome to the Chompman tutorial series. Based on the beloved classic arcade game Pac-Man, this project was created to be an easy-to-follow step-by-step guide that would give you the tools, techniques, and experience of creating a full game from start to finish. We have made all the original assets that we created for the game completely free. Links in the description below. For this project, if you wish to follow along step by step, you will need to first download the Chompman project files, both of which can be downloaded in the downloads area of the tutorial site or from links in the description.
In our last Chompman games without code using Bolt video, we improved our ghost AI by varying our ghost behavior. In this video, we'll create a spawning system for both our player and our enemy ghosts, as well as set up the mechanics for what we want to happen if the ghosts are eaten or the player is killed. To begin, we'll open up our level 01 scene, and we'll start by going to our stage manager state machine. In our stage manager state machine, let's go to our level picker state. So the logic that we want to create for this level is fairly simple. Similar to the way we instantiated and spawned our power pellets and power up, we want to also do this for both our player and our ghost characters. However, unlike our dots and power ups, we want to specify the location that we want each character to spawn. To do this, we're going to use a game object instantiate on original parent node. So let's duplicate our onEnter state, and let's create one scene game object variable, which we're going to call Chomp Prefab. And let's create another object game object variable, which we're going to call Player Spawn Point Transform. And for our Chomp Prefab variable, let's place the Chomp character force value. Next, let's create a game object and place it where we want our character to spawn. Something to note is, despite the position, we want to assure that this game object is set to 0 in the Y. Once we have the object set in our desired location, we need to remove the collider, and we can either turn off or remove the mesh render. And let's also rename this game object to player spawn. And with the object placed and renamed, we want to then set it as the source for our object spawn point variable. With that complete, let's now move our two new variables into our graph. And we want to connect the player spawn point transform variable into the parent transform for our game object instantiate node. And we want to connect our Chomp Prefab variable into the original section for our game object instantiate node. And we want our game object instantiate node to output to our set variable, and the variable that we're going to set is our player active object variable that we created in our last lesson. With that complete, let's remove the value that we have in our player active object and delete our player, and let's test out our functionality before we continue. So we can see now that we have our player spawn, we have all of our controls working. And if we go into our scene objects and we look at our active player object, we can see that we have that Chompman clone that can be found as a child under our spawn point object that we just created. With our player respawn created and working, the next thing we need to do is create our ghost respawns. But before we do that, we need to finish up our ghost state machine and make a prefab for our orange and pink ghosts. So let's select our ghost prefab and go to our ghost state machine. And let's go into our red ghost super state. And let's go under our movement, and we're going to go under the eaten state. Currently, when the ghost is eaten, it deactivates our ghost. But instead, we're going to destroy this game object and then respawn it at its spawn point. We also need to tell the game to give the player the appropriate points for eating our ghost. Since the points for eating ghosts multiply the more you eat on one power up, we'll need to make a variable that keeps track of how many ghosts are eaten on a single power up. To do this, we're going to create 4 scene booleans, one for each ghost. For our booleans, we're going to call them is ghost red 8, is ghost blue 8, is ghost orange 8. Is ghost pink 8. And for our last variable, we're going to create an integer, and we're going to call that number of ghost 8. First, we want to start with a blank set variable scene node. And since this object is a prefab and isn't in our scene, we can just copy and paste the name of the variable from our scenes variable tab. And for the value, we want that to be a boolean, and we're going to set that to true. In order to better optimize our scene, instead of an update event, we're going to use a custom event trigger. And we're going to name this custom event Ghost Was Eaten. However, for the target of our custom event trigger, instead of using this trigger to trigger an event within our Ghost state machine, we're going to trigger an event within our stage manager. However, to do this, we'll first need to tag our stage manager game object. This way, despite our scene, our enemy character will always have the correct stage managers to send that event to. In order to do this, we need to first create a new object variable, which we're going to call stage manager object. Next, let's drag our stage manager object, and we're going to connect that to the target of our custom event trigger. And to get the value of our stage manager variable, we're going to define that the moment the state machine starts. Next, let's go into our stage manager state, and let's create an any state. With our any state created, now let's create a flow state, which we're going to call Ghost Respawn. Let's make a transition from our any state to our Ghost Respawn state. And in our transition, we're going to use our custom event. And the custom event we want to send is the Ghost Was Eaten event trigger. We can also plug our player respawn as well as our game over state into our any state as well, since we know that these states will be consistent no matter which level the player is on. And for these states, we can simply make a transition from our any state into our player respawn state as well as our game over state and copy our transitions that we're using in our level 01 state. Or we can simply create a custom transition like we did for our Ghost Respawn state in order to not have to rely on our update node and better optimize our game's performance. Let's create an application variable, and let's also create an application variable for our scene variable game objects as well as our game manager game objects. Since we may have multiple objects using our stage manager, our scene variables, and our game manager game objects. And we're going to change our variable within our Eden state from our object variable into our stage manager application variable. So let's now create a flow machine, and we're going to create this on our macro manager, and we're going to make this an embedded flow machine, and we're going to call this set application object variables. And in this flow machine, we're simply going to set the values for our scene variable objects as well as our stage manager and game manager objects by finding the tags and setting the values for our variables. With our set application object flow machine complete, let's now create a spawn point for our red ghost enemy. Let's now go into our state machine level picker state. Before we continue, let's first change our chomp prefab scene variable into an application variable. This way it will be much easier changing our character between scenes or if we wanted to replace it with another character. Let's also make an application game object variable for our red ghost prefab. Let's now change the name of our chomp prefab scene variable into player active prefab. And let's also remove our player active prefab value. For the time being, we could simply change the original source of our instantiated object into our chomp character prefab. Next, let's create two variables, one for our red ghost spawn point transform, and the second for our instantiated ghost object. Next, let's duplicate our nodes for our player spawn. And let's change the variables to our red ghost variables. Before we continue, let's delete the ghosts that we have in our scene and test the mechanics we've created so far. So we can see that we have our ghosts spawning in our scene as well as our player. If we go into our spawn ghost state machine, we can see that we have everything working. If we also go into our macro, we can see that we've set all of our application variables with our tagged objects that we have in our scene. Our player is destroyed. We can see that we are sent to our player respawn. Since we have one current life left, and if we go back and we change our life to 0, you can see that we are now taking to our game over scene. Our variable is game over is true, and we can see our game over state is set within our stage manager. In the next lesson, we'll finish our ghost state machine by creating the ability for them to change colors once the player has eaten the power-up. We'll also create our orange and pink ghost prefab, as well as finishing our ghost respawn and our player respawn system.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, interviews, and free game asset giveaways.